Let's talk about the fundamental counting principle and factorial notation. So this is going to be module 1 of combinations and probability, and this is going to be the first module where you really tap into the idea of outcomes, probabilities, and such like that. So the first thing that you should know is what n factorial is defined by. So if you look at n factorial here, if you've never seen it before, it just means 1 times 2 times 3 times blah blah blah, all the way till the number n. So if you take 5 factorial, this would simply just equal to 1 times 2 times 3 times 4 times 5. And this is all equal to 120. So that's it. Another important note that you should know is that 0 factorial equals to 1. And you can quickly prove this, but I'm not going to do that in this video. But you can just search up why it is like that. Very important. And now, the FCP, the fundamental counting principle, states that if a task has A options, then B options, then C options, and each choice is independent, the total outcomes equals to A times B times C. So we're talking about a scenario when you have different choices to make, and sequentially, you can make independent choices. And then it tells you the total outcomes that can be possible by these options. So an example that I can kind of think of on the spot is, let's say you go into an ice cream shop. Now, there's a bunch of things that you choose when you get ice cream. So the first thing that you would choose is the type of cone or a cup, let's say. And let's say the very basic one is just basic, and then you can get a waffle or just a cup. Okay, so we have 3 choices from here. And then, after you choose this, you get to choose what kind of ice cream you want. So, let's say there's 4 flavors, and there's strawberry, chocolate, mango, vanilla, and then of course, on each choice that you make, you have these same choices. And then, once you've chosen your flavor, you can ask yourself, do I want any toppings? And that's completely your choice. So let's say there's Oreos and let's say there's nuts, right? And of course you can choose this for anything, any flavor that you choose. And I'm running out of space here, but you get this. And now let's check on each sequence, each step, how many choices you had. And later, let's look at how many total outcomes there were. So the first is going to be 3. You have 3 choices: basic, waffle, or cup. And then when it came to the flavor of the ice cream, you had 4 choices. So you had 4 choices: strawberry, chocolate, mango, vanilla. And then you had 2 topping choices. So I'm gonna write 2 here. And now you can see, according to the fundamental counting principle, you can say that the total outcome equals 24. So 3 times 4 times 2 equals 24. And you can quickly verify this because each outcome is summed up to 24. So there were 24 total outcomes of ice cream that you could have gotten. And that is what the fundamental counting principle talks about. So let's talk about permutations now. Permutations is an arrangement of objects where the order matters. So if you look at this example with ABC, we get 6 permutations. ABC, ACB, BAC, BCA, CAB, and CBA. And this is actually 3 factorial. And this is because ABC has 3 objects. So the number of permutations naturally means that there are 3 times 2 times 1 arrangements possible. So if there are 3 slots where you can put in each letter of ABC, the first slot you have 3 choices. You can put in either ABC, so you have 3, and then the second slot you can put in the 2 remaining objects, so there's going to be 2, and then the last one is just going to be the one left over. And as you can see, there are going to be 6 permutations that you can get. So this is summarized here, where if there are n distinct objects in a row, the number of permutations is going to be n factorial. However, you have to note that if there are repeats in the objects, so let's say you have something like A, B, C, this is not just going to be 4 factorial because of the fact that we have 2 A's here. So to account for this, what we have to do is use this n factorial over n1 factorial and n2 factorial, where the n factorials at the bottom are counts of identical objects. So let's take a look at this example here. Find the number of distinct arrangements or permutations of the letters of the word balloon. So as you can see naturally, you might think that the number of permutations is simply just 1, 2, 3, 4, 5, 6, 7 factorial. But remember, if there are repeats in the objects, we have to take into the fact that there are going to be repeated permutations as well. So in order to defy that, we have to divide this by the number of L's. There are 2, and it seems like we have 2 O's. So that will be the answer, 7 factorial over 2 factorial times 2 factorial. And this will represent the amount of permutations of balloon.